When solving algebraic limits, the first thing you should try to do is just plug in the number in which x is going to. In this case, x is going to 4. So let's plug that in. So it's going to be 3 times 4 squared minus 2 times 4 plus 5. Multiplying this out, this gives us 3 times 16 minus 8 plus 5. Multiplying it further, 3 times 16 is 48 minus 8 plus 5. 48 minus 8 is 40 plus 5. So therefore, this limit is equal to 45. Just like the first problem, first thing we should try to do is plug in the -1 in for all the x's. But notice that when you try to plug in -1 into the denominator, get -1 plus 1, which gives you 0. So right away, we know that we can't just plug it in. And this is why this is a medium level problem. And so for this particular problem, what we first need to do is look at the numerator and notice that we can factor that quadratic polynomial. To do this, we look at the 2 here. We find factors that multiply to 2, but then adds to 3. In this case, those factors are x plus 2 and then x plus 1. The denominator stays the same, so we just write down the x plus 1. Now, because we factor it, notice that the 2x plus 1 perfectly cancels out, leaving us just with just x plus 2. And now we can just plug in the limit. In this case, as x goes to -1. So plugging in -1 into this, we get -1 plus 2. So therefore, in this case, the limit is equal to 1. So for these two problems, they're classified as hard because A, we can't just plug in the numbers, just like the very easy first problem that was easy to get an answer. And B, there's not a simple factoring that we can do to cancel things out. For the first hard problem, when you have a radical and then combined with another term, the best strategy is to multiply for the term with the radical by its conjugate. In this case, because the numerator has a radical, we're going to multiply the numerator by the conjugate. We're going to do it to both numerator and denominator. So this time, we're multiplying by the square root x plus 2 plus 3 over the square root x plus 2 plus 3. If we multiply out the top, if we FOIL everything out, because the terms are of opposite sign, and that's why we use conjugate, we only need to multiply front two terms times each other and the last two terms times each other. So doing this multiplication, we will get then x plus 2, and multiplying the 3's together, we get a minus 9. And for the bottom, we just leave everything as is. Don't multiply anything, so just leave it x minus 7 times all of that square root of x plus 2 plus 3. Notice that if we simplify the top, the plus 2 and the minus 9, that gives us a x minus 7 on top. So for the bottom, we just leave everything alone. Notice that we have an x minus 7 on top and x minus 7 on the bottom. So just like the earlier factor that cancel out, we cancel out the x minus 7. So this just leaves us with a 1 up top and the denominator of square root of x plus 2 plus 3. Because we removed the x minus 7 on the bottom, we no longer have to worry about the 0 in the denominator. So at this juncture, in our very last step, we can now just take the limit value of x goes to 7 and plug in at 7 into the square root. So then this gives us 1 over square root of 7 plus 2 plus 3. 7 plus 2 is 9. So then this becomes 1 over square root of 9 plus 3, which square root of 9 is 3. So it's 1 over 3 plus 3 with the final limit equaling to 1 over 6. For this next hard problem, notice that we don't have any conjugates to worry about, but we have two different fractions. So the best thing to do when you have two different fractions is try to get common denominator and combine the two. But notice that the second fraction, the x squared minus 25, that's just a difference in squares. So we can rewrite that as x plus 5, x minus 5. So then to do common denominator, we know that the common denominator is x plus 5, x minus 5. So the first term just needs to be multiplied by x plus 5 to top and bottom. So then we work this out. Our first term in the numerator of the first term is just 3 times x plus 5. And then combine it with because they have the same denominator, we can combine with the second term, which in this case is 15. And the denominator of both of them, because we now made them the same, is going to be x minus 5 and then x plus 5. Cleaning up the top, we distribute the 3 into both sides, then we get 3x plus 15 minus 15. The denominator doesn't change. So you see in the numerator, you see the plus 15 and minus 15. Well, those two terms cancel each other out. So this gives us 3x over the same denominator to 4. So notice that even though we were able to simplify as best as we can, If we put the limit of value going to 5 into the equation, we still get a 0 in the denominator. In this case, our only option to figure out what the limit of this function is to do the right hand and left hand side limits. So if we do then the limit as x goes to 5 from the right hand side, so from the plus side, which means us choosing values that are getting closer and closer to 5 from the greater side. So you can choose 5.1 and 5.01, put that into the equation, and you see that the numbers get bigger and bigger faster. So we know the limit going from the plus side is equal to infinity. And let's do the same thing as the limit going from the opposite side. So if we need to come from the limit as x goes to 5, in this case, coming from the left-hand side. So now we just choose values that are smaller than, so we first choose like 4.9, and then we choose 4.99, because again, those values on a number line here is less than 5. When you put that into our equation, you see is getting more and more negative. So therefore, the limit from the left-hand side as you go to 5 is equal to negative infinity. Because these two limits do not equal each other, the limit does not exist.